The first ionization energy is recorded as follows from a photoelectron spectroscopy experiment. Determine the wavelength of light required to ionize one atom in nanometers, and we're given Planck's constant and the speed of light. And assume the kinetic energy of the ejected electron is 1.248 electron volts, which we can convert to joules. So we know that the energy from the electromagnetic radiation source is equal to Planck's constant by the frequency of light. And that's equal to the ionization energy plus the kinetic energy of the ejected electron. Now the binding energy is given in megajoules per mole. So we need to convert it in units of joules per atom. So we get this in units of joules per atom, and the kinetic energy of the ejected electron can be converted from electron volts to joules. And then you can substitute into this expression and divide through by Planck's constant, which gives you the frequency of light, which will be in units of 1/2. And the wavelength of light can be obtained using the following expression, where the speed of light is the wavelength by the frequency. Then using this constant for the speed of light, you'll obtain the wavelength in units of meters, then convert this to nanometers. Then use the correct number of significant figures and post your answer in the comments.